You might remember that when we discussed simple transistor amplifiers, we spent quite a lot of time discussing on how to bias them. Well, another way of making a transistor circuit which will conduct over the whole input cycle is to use two transistors, one which works over the positive half of the cycle and the other which works over the negative half. Such a circuit is shown on the screen and is known as a push-pull or Class B amplifier. You'll notice in this case that there is an NPN and a PNP transistor in the circuit. On the top half of the cycle, transistor 1 amplifies the signal and transistor 2 is off. This is because its base voltage is the wrong way round for conduction. On the bottom half of the signal, transistor 2 amplifies, but transistor 1 is off. The problem with the configuration on the screen is that actually transistor 1 doesn't turn on until Vin is greater than 0.7 volts, and similarly transistor 2 doesn't turn on until Vin is less than minus 0.7 volts. This causes a piece of signal to go missing and results in a type of distortion called crossover distortion. This means that there is usually a small circuit added to the basis of the transistors to provide the required 0.7 volts bias to each. This circuit can consist of resistors, diodes, or another transistor. Although the push-pull amplifier might seem unnecessarily complex compared to a simple single transistor amplifier, it does have the advantage in that it is more efficient. This is because only one transistor is biased on at a time, as opposed to the simple single transistor amplifier, which is always biased on even when no signal is present. This makes a push-pull amplifier very popular where high-powered amplifiers are required, for example in audio or radio frequency high-power amplifier circuits.